Okay, we're ready for notes for 7A for the Math 4 course. And one of the first things we're going to wind up doing is choosing a bowling team. So I thought this would be a fun meme to put at the front of this. That would be awkward. All right, today our goals are, that we can distinguish between statistical questions and stuff that doesn't make good statistical questions. We're looking at the choices that we make as far as statistical questions. Um, Also, we're looking at the concept of variability within a data set. Um, that is to say, um, when I am looking to investigate something, is there the possibility of different answers? Or am I going to get the same thing every time? This was kind of like I joked at one point about standing in front of the Longhorn Saloon and asking people their favorite music style. All you're going to get for the most part is country music. Um, so, you want to pursue something that is going to have some variety in the answers so that you can, take a good solid statistical look at it and not, um, and sometimes this gets into the question of bias. Um, there are some that will conduct a survey knowing that the answers will be biased. That they know that the people that they have chosen to ask are going to answer in one particular way. Um, and that is, intentionally introducing bias into the survey. You can still do it unintentionally, and that's the thing that you try and take extra care to watch out for, that you're not accidentally introducing bias into something. But anyway, we'll get into that in a little bit. Now, this is a showing of 4 different people that it gives you a histogram of their bowling scores for the last 25 games. And over to the left, it gives you the mean, the median, the standard deviation, and the interquartile range. Now, first of all, I guess I need to explain for those that have no idea what you do in a bowling alley. The goal is to get as many points as possible, and in bowling, the maximum possible score is 300. So that's why all the graphs stop at 300. Now, understand that, the mean and the median, we've talked about that before. That is more of an indication of the middle. But the standard deviation and the interquartile range gives you more of an idea of how wide does this thing spread out. Now, I mean, person A and person B is a perfect thing to look at, because person B, you'll notice that all of his game scores are all clumped between 120 and 160, all 25 scores. And his mean and his median are like 2 points away from each other. His standard deviation and interquartile range are less than a point away from each other. So this guy is about as consistent as they come. And, 131, 129, that's not a bad average. For your average weekend bowler, that's not bad. I think as a teenager, participated in bowling leagues, some in just, the local area, but also as I got older as a teenager, I participated in some as a part of like a church league. And I got to the point to where my average would drift somewhere between 125 and 150. I was one of those that I had a really weird step in my bowling throw. And I would generally shoot like 100 for the first game, and then I'd warm up and I'd get really hot and I'd do 150 for the second game. And then, the whole issue is you've got 3 fingers in those holes in the ball, and after a while, your fingers can start to wear out, and so mine would. And so I'd start to drift back down to 125 because I'd start to get tired. Usually when you're bowling, you play 3 games, at least in competitive bowling. So anyway, so you notice that person B has very little spread Their standard deviation, their interquartile range is all, right close to, at hand there. Now, when you look at person A, their median and mean are all both 111, 118. They're not that far from each other. They're both in the 110s, and interquartile range says that it is 44 wide, and standard deviation is about 33, which means that plus or minus one standard deviation would be about 66 wide. But if I'm looking back at where the mean and the median are in the 110s, I notice that about half of the scores are in the 80s, 90s, and 100s. And then about half of the scores are in the 120s all the way up to 200. So what's going on with person A is that, half the time they're fairly consistent in 80 to 110 or 120, whatever. If they're going to be inconsistent, it's in the upper range. That's not such a bad thing. If somebody's going to get off their usual game, you'd rather them go high rather than go low. So let's look at the other two, person C and person D. Person C, their mean is 133, their median is 145, so they've got a higher average. But look at where their scores are. Their scores are all over the map. Their interquartile range is 74. Their standard deviation, 45 this way, 45 that way, is a range of 90 points. So, this person may have a higher average, but you don't know what they're going to do from one game to the next because they're all over the map. And so this is one of the ways that you look at statistics like this. Now, this guy is fairly consistent. His median is 103. That represents half the numbers are below it and half the numbers are above it. Well, there's this two games out here that are between 290 and 300. And everything else is down here. So it's like usually he lives down here, but every once in a blue moon, he gets lucky up here. And that drags his average up by 10 points. But when you're living most of your life down here, is that worth, do you really want somebody whose typical score is around 100? Every once in a while he'll get lucky, but most of the time he lives down here. Whereas you go back up to A and B, and, this person typically scores around 130. This person typically scores somewhere in the 110s. And then you go down to person D, and their median is 103. You can't trust their mean. Their mean may say 116, but that's only because of these guys up here. These outliers up here are dragging the average upward to a place where you can't really trust it. You can trust the median more so than the mean in this case. So, when I would ask the class, so which two would you pick for your bowling team? Most, I had a few odd answers, but most everybody was saying A and B. They felt like these were the two that would be the strongest additions to the team. This guy was just way too inconsistent. And this guy, just kind of lived down here, which is not an average that was going to be helpful to the team. So anyway, now let's move on and let's look at some of these bullet points that I've got in your notes. When we're talking about making good statistical questions, you want a situation that allows for data collection. There's no use in chasing a statistic if you have no way to collect data about it. I'm trying to think off the top of my head what would be some random statistical question. In the Civil War, how did the people of Virginia feel about the war during the year 1863? Well, how are you supposed to go back to 1863 and poll them? You can't. So you need to come up with questions that allow for data collections that allow you to find data. Either if you can't go out and survey it and get the data yourself, then you need to get somebody else's data and work with that. And again, you need to allow for data collection. There also has to be variability in the data. We talked about that earlier. If I go to a country bar and ask about their favorite style of music, I'm going to get the same answer. Um, so I need to have questions that allow for variability in the data. Um, a little bit later on in the notes, we'll look at an example where somebody was wanting to look at the statistical question of how much time does your average sixth grader spend on homework each night? Now that's a fairly decent statistical question because you're going to have some that spend 30 minutes and some that spend 60 minutes and some that spend zero, and you're going to have some variety in the data that comes back. Now, if you asked a question like, how much time did Egbert spend on his homework last night? Or you're going to get one data point. You're going to get one answer, and there's no variability in that. There's only one correct amount of time that he spent last night. So, you want to ask a question in such a way that you're going to get some variability in your data, that you're going to get some variety of answers. The other things about the statistical questions is that you have to figure out who it is that you're studying. Who's your population of interest? If you are you trying to approach all students of Enloe and ask them what's their favorite flavor of ice cream? Who's the population you're after? And then once you've identified the population, you got to figure out what aspect of this population is it you're trying to study. Is it their favorite flavor of ice cream? Is it their favorite shoe that they wear? This could go in a number of different places. This is kind of the starting place for statistical questions is that they need to have all of these aspects. Now, issues that arise along the way is vagueness. To me, vagueness would be a question like, walking up to the man on the street and saying, "How do you feel about the economy?" You're not. That's a very vague question, and your answers are going to be so different. You're literally going to have a different answer for each person. You also have to be careful about biased tones, and we've talked a little bit about this. Sometimes you have to be careful that you don't. One of my favorite memes is, what is your least favorite style of music, and why is it country music? Yeah, those kind of memes that do stuff like that to where the opening question sounds reasonable enough, but then they turn it around and it's kind of like there's only one answer that they're looking for. That's a biased tone. All right. So, of course, then there's wordiness. If you take too long to get to the point, or if you're asking your question in such a way that the people are like, "What? What did you just ask me? Give it to me in English, please." Try and make it so that people will want to answer. What's going to happen is if you get it too wordy, they're just going to look at it and say, "No, I'll pass," and then you get nothing. All right, confusing answer choices. Now, this was something, interestingly enough, over this past weekend, Wake County Schools sent out a survey to the teachers wanting to kind of gauge where we were at with going back in the building. And there was one question that the way it was asked, and it was like, nobody wanted to choose any of the answers. It's like they were trying to force us into, one of the answers, and none of them were right. None of them were acceptable. And, I got on some social media chat groups and we talked about this one particular question on the survey that, nobody wanted to answer that one. Because the answer choices were not realistic to us. They did not, we couldn't pick on one answer and say, yeah, that one, that's how I feel. And so you got to be careful about the answer choices that you give them, because if you're not if again you're painting this in one direction, and people aren't thinking in that direction, they're going to get confused about what you're after. Let's see now, unreasonable or unrealistic responses. The one thing that I used to hate in surveys, they would have they would ask you a question and you're supposed to respond, do you agree or disagree? Do you strongly agree or do you strongly disagree? And, if you're lucky, they'll give you the option of, I don't care, or I don't know. And, because there are some situations where I can't say that I agree or disagree. I have to fall in the middle somewhere. And what really ticks me off are the surveys that do not give you that middle option. They force you into it. You either have to say you agree or disagree at the very least. And it's like, I'm just not in a position to give either one of those, so and of course there are also other ways that your responses can be unreasonable or unrealistic. Now what they mean by deterministic is that there's only going to be one answer. That would be like the question of how much time did Egbert spend on his homework last night. There's going to be one right answer to that. And so there's no variability. There's no variety of answer there. There's only one right answer. And so you want to try and avoid those questions as well. Now, the checklist for good statistical questions. The variable of interest is clear and available. A couple of years ago, I sent off my Math 3 students to make a survey, and they all had to choose their own topic. Everybody in the room had to have a different topic. And you would have favorite ice cream, favorite shoe, favorite Avenger character, all sorts of variety there. And I said, when you go and you do your survey, you need 3 choices at the very least. And then you need a 4th choice that says other. That if somebody is, if you're asking their favorite flavor of ice cream and you only give them chocolate, vanilla, and strawberry, what happens if none of those are their favorite? They're gonna want that other option. So make the variables of interest clear and available. The thing about ice cream is that there's such a variety of flavors that you're going to wind up with a significant number of people choosing others simply because they don't want the boring flavors. Mint chip or rocky road or something like that. So these are the hazards that you face in doing surveys. Now, the population of interest is clear. You've got to have a clear picture of who it is that you're trying to survey. We talked about at one point about that student survey on CODAP that had the 40 different questions. The who had the longest left hand and stuff like that. And when we looked at the ages, I think I did this in just about every class. We noticed that there were some that would pop up that were, said they were like 40 and 50 years old. And we said, wait a minute, we want just students. We don't want the grown-ups in this. And so we would, take those data points and we would hide them and look at what was left. And so, you got to have a clear eye for what your population of interest is and, kind of weed out anybody that doesn't fit into that. The intent has to be clear. Where are you going with this? What is it that you hope to find with the statistical question? Now it needs to be a question that can be answered with the data, whether you collect it yourself or whether you use somebody else's data. Again, you're answering a question with data. And sometimes I worry about where we're at with the coronavirus. Because some of the different studies that have been, put out there and said, oh, we can trust this study, but anybody who digs into it and suddenly realizes, they didn't include nearly as much data as what they should have. One that comes to mind was about a month ago, we had a study from Duke and Carolina that said that, it was safe. The kids in school were not the cause of the spread. But several people that dug into the nuts and bolts of it realized that, they only did 11 counties, and they did it back in August when nobody was in school. And, you need to have data that you can use, and plenty of it. The more the merrier. Let's see now. Question is worth investigating. It is interesting. It has a purpose. Like I said, who cares? If your left hand is longer than your right or something like that. Why is that? I mean, that may be a curiosity. That sounds like one of those clickbait kind of quizzes you find on social media. But if you're going to spend your time playing with the data, let it be for something that is going to be of interest to other people. You know. And then lastly, the question allows for analysis of the whole group. Um, this gets back to the issues I think I'd shared at one point in my radio career about the Arbitron ratings that were misleading one year, that they had sampled 100 diaries out of 40,000 people in Greensville County. And, they said, this is what everybody likes. And, make sure that what you are doing is applicable to the whole group, and not just part of it. Um, so anyway, all right, let's move on. All right, I think I've decided to pause here and do the rest of the notes in a separate video.